So let us look at question 5, which is saying using compound angle identities to find the exact value. So compound angle identities is something that is very simple and straightforward. You just have to know um, the formulas for some and different. So now we have sine. If at all we have sine a plus b, this is going to give us sine. Okay, this is going to give us sine a cos b plus, I want you to see the trend which is happening here. Okay, plus, then it's going to be sine, since we have already used the a, then for sine now it's going to be sine b, then cos a. Simple, right? So the next thing is when there is minus, sine a minus b, it's the same thing, sine a cos b minus sine b cos a. That is for sine. If we use cos a plus b, this is going to change now because there is cos is bit stingy, so it will be cos a cos b. If there is plus here, then there will be minus, then we are remaining with sine a sine b. This is going to be the same for cos a minus b. It's going to be the same, but the sign is going to change. We'll have cos a cos b plus sine a sine b. What of for tan? So tan, but I think I gave you for tan a tan b is basically tan a plus tan b divided by 1 minus tan a tan b. For if there is minus, if at all there is minus a minus b, this sign is going to change, and this is going to change to plus, this is going to change to minus. That's the only difference. The rest are the same. Using these compound angle identities, I think we can go ahead and now find the exact value of these. Let us start with part 1, which is part A. It is talking about sine, so we have sine 15. Now, for sine 15 degrees, you look at the special angles. Remember the special angles we have. You can say 0, but no. I'm going just to say 30, 45, 60, and 90. So we have 15. 15, there are two special angles, which when we add, they're supposed to give us 15. It's not going to be possible, but minus. I think if I do 45 minus 30, this gives me 15. So I'm going to use this. Meaning that this is basically the same as sine 45 minus sine 30. Degrees. So when I do this, now I'm going to use the formulas that we have just come up with to find the exact value. So let's go ahead and do that. So this is going to be sine 45 degrees times cos 30 degrees. Since there is minus, it will be minus. Then sine 30 degrees times cos 45 degrees. When I do this, we can now go ahead and, of course, do the thing. Okay. So let us go ahead and look at this. Yeah, let us go ahead and look at this. What is sine 45? So it's very important for us to know the special angles. That's why I've given you the table that is going to help you to understand this. Okay. Sine 45 is root 2 over 2. So Sine 45 is root 2 over 2. But before we go there, I want you to understand one thing. Okay? I want you to understand one thing. We are looking at 15 degrees. So 15 degrees is in the first quadrant. Okay? So sine is positive in the first quadrant. Cos is also positive. So there's nothing like for me to start thinking of putting negative. No. 15 degrees is in the first quadrant. So it's going to be positive. So there we go. Sine 45 is root 2 over 2 times cos 30 is root 3. Using this, cos 30 is root 3 over 2. I'll put these in the brackets, minus sine 30 is 1 over 2. Then times cos 45. Cos 45 is root 3, root 2 over 2. It's root 2 over 2. So what can we do? We go ahead and say root 2 times root 3 is root 6. Then 2 times 2 is 4. Minus, that is going to be root 2. Then this is going to be 4. The denominators are the same, we add the numerators. So we end up having root 6 minus root 2. Then we divide this by 4. I'll end there. Another person can go ahead and factor out root 2. You factor out root 2, here you remain with root 3. Here you remain with 1. Then you divide it by 4. It's basically the same thing, but don't even waste time, just end there. So that's the answer. Now let us go ahead and look at question B. It's cos. So it's the same thing, but just cos. It's the same thing. So we still have the same things. We have cos 45 degrees minus 30 degrees. Remember, for cos, it's going to be cos 45 degrees, cos 30 degrees. If there is minus, you use plus. Sine 45 degrees, sine 30 degrees. Simple, right? So we are still looking at this. There's nothing like to put negative because 15 is in the first quadrant. So everything will be positive. Okay? Everything will be positive. So let us do this. Now what is cos 45? Okay, cos 45, it should be root 2. I think I've mastered this now. Cos 45 is root 2 over 2. Then what of cos 30? Cos 30 is root 3 over 2 plus, what is sine 45? Sine 45, sine 45, sine 45, sine 45, root 2 over 2. Sine 30 is 1 over 2. If we multiply this, we end up having root 6 divided by 4 again, plus 2 over 4, which is basically the same thing, but only that here is positive. That becomes my answer. Let us go ahead and look at 75. Again, it is in the first quadrant. So it is in the first quadrant. I don't have to struggle because everything is positive already. So there's no need of me adding negative. 75 is in the first quadrant. So I'll use the same thing. So we are going to have tan 75 is basically the same as 45 or 45 plus 30 degrees, which we know that this, I'm supposed to write it like this, is equal to tan 45 plus 30 degrees. This gives me tan 45 plus, using the formula, tan 30 degrees divided by 1 minus, because there is plus, down there will be minus, on top there will be plus, tan 45 times tan 30. What is tan 45 and what is tan 30? Tan 35, tan 45 is 1, tan 30 is 1 over root 3. So tan 45 is 1, tan 30 is 1 over root 3. That's what we have said. Not so. 1 over root 3. So this is going to be the same. 1 minus tan 45, we have said is 1, times tan 30, 1 over root 3. So I can write this side 1 plus 1 over root 3 divided by 1 plus 1 over root 3. So this should be minus now, down part. Like that. Let us see. So let us first simplify the top part alone as well as the bottom part alone. So if we were to simplify this, we'll end up having, if you have if you have 1 over 2 plus 1, it's basically the same as 1 over 2 plus 2 over 2, because 2 over 2 is 1. So here is the same thing. I say root 3 over root 3 plus 1 over root 3. That gives me 1 already. So the numerator will be added. So we'll have the top part, we are going to have root 3. Okay, root 3 plus 1 divided by root 3. Now this is division. I'll just put it here. This is going to be the same thing if you simplify it, but only that there will be minus. So it will be root 3 minus 1 divided by root 3. Now if you go further and simplify it, you end up having this times, now you get the reciprocal of that. It will be root 3 over this. Okay, so these will cancel. When those ones cancel out, you end up having root 3 plus 1 divided by root 3 minus 1. When you reach at this point, you can rationalize the numerator and the denominator. I don't think there will be anything that is going to change. If you want, you can leave it the way it is. You want to rationalize the denominator. Okay, so it will you can actually just change the sign here. So you choose where to change it. You can either change the sign for third or this one. You end up having the same answer. So I'll change just the one in between. I'm getting the conjugate of that. So let's see. Root 3 times root 3 is 3. Root 3 times 1 is root 3. 1 times that is again root 3. 1 times 1 is 1. The down part, just square the part having negative, and you end up having 3 minus 1. When you do that, it will be 4. Well, 3 plus 1 is 4, plus 2 root 3 divided by 2. So if you divide both sides, it will be 2 there, 1, and I'll end up having this. So the answer actually for this is 2 plus root 3. Interesting, right? It is very much interesting, but you have to be very much careful so that you avoid mistakes. Okay? Yeah, that's the most important thing. Now let us look at the next one. Let us look at the next one. Let's first create space. we create space, sine 165. So let us look at what sine 165. But sine 165, if I get two special angles, it's going to be, I know it's going to be bit challenging for me, but I think I know if I do 120, because 120, if I do 120 degrees, okay, if I do 120 and I think 60, it should be the same. 120 is in the second quadrant, so 180, 60 is going to be the same. So I think, not I think, 120 and 60, sine 60 and sine 120 is the same thing. So I'm going to use sine 120 degrees. Okay, I'm going to use sine 120 degrees. I'm going to use sine 120 degrees plus, I need to add what? Another one I think has to be special angle 45. It's going to be 165. Yes. So I should take note that sine 60 and sine 120 is going to be the same. Okay. So when you reach at this point, you just say sine 120 times cos 45 sine 160 times 45, then plus, now it's going to be sine 45 and then cos 125. So cos 125 is same as again cos 60. So that is going to be the issue now here. But for this one, we need to be very much careful, because we need to look at the 120. Okay, we need to look at the 120. That is going to help us to know whether that is going to be negative or positive. So we look at this. The angle that we are talking about right now, it is in the second quadrant. So in the second quadrant, all student take chamber. Only the sign is going to be positive. Cos I have to assign negative, because in the second quadrant, for this one we are following this 160 is in the second quadrant. So cos is negative in the second quadrant. For cos, I should always include the negative. Does that make sense? Yeah. So I have to include negative. Yeah. So I think we can continue that, doing that. We can continue doing that. Let's see. Sine is, we have sine 120 is in the second quadrant. Not so. Sine 120 is in the second quadrant, but in the second quadrant sine is positive. 120 is in the second quadrant, so we are going to assign negative, or we are going to assign positive. So this is same as sine 60. Like I said, sine 60 is root 3 over 2. So that is going to be positive. Root 3 over 2. What is cos 45? Now we are looking at this term. Forget about, for now, I want you to forget about 165. We're now dealing with these angles. Cos 45. This 45, okay? This 45 is in the first quadrant. So we're going to assign this as positive as well. So when I go here, cos 45, root 2 over 2. So I'll say root 2 over 2. Plus sine 45. 45 is in the first quadrant. Sine is positive there. So what is sine 45? Sine 45 root 2 over 2. Here we go. 120 is in the second quadrant, only sign is negative, is positive. So this one we should do, remember to put in. So now what is cos 120? Cos 120 is the same as cos 60, okay, which is 1 over 2. So it will be negative half, like that. So this will be square root of 6 divided by 4. Because of this negative, this is going to be minus root 2 over 4. So the final answer will be this. That's the answer. That is the answer. Okay, that is the answer. So if you go to part B, this is going to be the same thing. You are just changing sine, cosec. So this is basically the same as 1 over sine. So pi over 12. So you say times 180 divided by pi. Pi and pi will go. So we have 6 there, 2, 6 here, 3. So it will be 15 degrees. So this is going to be the same as this one. It's going to be 15 degrees, which is going to give us 45 minus 30. But I want you to remember one thing. Sine 15 we found, if you remember the answer we found for part A. For sine 15, we found that it was root 6, I can remember very well, minus root 2, then divide it by 4. That's what we found. So this is the same as we are finding 1 over root 6 minus root 2 divided by 4. So this will be 1 divided by root 6 minus root 2 divided by 4, then 1 times 4 over root 6 minus root 2. So the final answer will be 4 divided by root 6 minus root 2. That will be the answer. I don't want to waste time because we have already found this. This is again the same as what we haven't found. But before we find f, I want us to do this. These things are just direct. You remember what we found on part C. So the answer we found for part C, if I go to part I, which is cot 75, because this is the same as 1 over tan 75. So this is 1 over, what did we find for part C? So I hope I'm not going to forget, but if I'm able to remember very well, we found 2 plus root 3. That's the one we found. So what you can do, you can rationalize. This is going to be 2 minus root 3, then 2 minus root 3. So if you multiply, you have this. Then here you square that, it will be 4 minus 3, which is going to be just 2 minus root 3. That is I. Yeah, that is I. There is I. So again, at the same time, if I go to H, I want us to do these things. If I go to H, I found this is cosec. Cosec 165 is the same as 1 over sine 165. So we found what's 165, which was part D. We found part D, not so. So part D, the answer that we found, it was root 6 minus root 2 divided by 4. So if I do this, is going to give me 4 root 6 minus root 2. That will be the answer. So have you seen that this one and of course which other one? This one I have found using the ones which I've already found. Okay, so it's not going to be complicated. It's not going to be complicated. Yeah, it's not going to be complicated. So here again, if you want, you can rationalize, but just leave it there. You can leave it there. What else are we supposed to do? Which other one are we supposed to answer? Which other one are we supposed to answer? Let's try part G. So that is basically the same as sec 7 pi over 12 is the same as 1 over sec is cos 7 pi over 12. So 7 pi over 12 times 180 divided by pi. Pi and pi will go. 12 here, it should be 15. Yeah, should be 15. So 180 divided by 12 is 15. So 15 times 7 is 105. So we are trying to find 1 over cos 105. If you remember very well, this is in the second quadrant. Okay, it is in the second quadrant, and we said when we do minus, it gave us 75. So for us to do 75, that 75 is going to be the same as this 75. Okay, so the special angle is 75. Now that 75 is going to be 45 plus 30. So you can go ahead and use this, the special angle. These are the ones we are going to use to find that. I believe the other one is cot 15. Cot 15 is going to be the same thing, but we are just using tan. Use the formula for tan, find the answer. That is going to be the same. Okay, so that's the whole idea about the compound angle identities.